G'day, mates. Introducing New Year's Resolution, or trying to debug an outdated tutorial that the people making the platform, oh gosh, didn't bother to apparently. Or, oh wait, no, I already said that. By someone who's way too tired for this shit. Dang, I interrupted myself. That is like competitive level self-sabotage. Okay. Also, if anyone has any more ideas for title cards, let's see. Feel free to. There we go. Feel free to leave them in the comments. Yeah. Here we are. So now, if all of you will remember last time, there we are. Okay. There's a delay, latency in the stream. These keyboard checks, this move collider, all of this was grayed out, and none of it was able to be used. And now I have changed to the version where it actually tells me from the tutorial I was following to go and download this version. Yep, I am in this. Now then. I still can't move. I do not know why I can't move. Let's see. Should I try and create wait.
First of all, go and open Game Maker for the entire level. This is a tile set that we're gonna use to design our level, the app
No.
sets for your project. First thing you're gonna load it, click Let's Go. Your new project.
Okay, let's see. Increase the quality to HD premium stuff. Okay. IDE V 2024. Yeah, okay, this is still navigate. How do I change this? Tools. Create local package. Windows. Build. That's run, debug, rerun, clean code, clean graphics, clean audio, create executable. Basically, this is supposed to be version 2024.11, and then there's some extra numbers, but this is 2024.14. I am not a rocket biologist, but I don't think those numbers are the same. And what the hell is this? Your device needs to restart to install updates. Select a time to restart. Nah. File. Preferences. Let's see. General settings. Start page. Boom. Image editor, spread editor, script editor, font rooms, text, languages, fit settings, platform settings, plugins, runtime, animative curve editor, asset browser, confirm dialog. No, thank you. Code editor 2 beta. Oh, wait. Restore defaults. No. Where is... it doesn't let me select the version. But yeah, there is something wrong, and I do not know what it is. So let's go over to... let's see, beta for Windows. No. One moment. Get rid of that. Game Maker. Proper capitalization. And then V2024.11.0 .179. Alright. Oh, it no longer functions. Well, it functions, it's just that once they're built, they no longer work. Which means it doesn't function. How am I supposed to...
of the camera. So I'll make this 160 by 90 get in the step event. Let's write this now. Here we are making a variable called tile map that gets the tile map of the second tile layer that we created, tiles underscore call.
Alright, what? Unlike the keyboard, check, press. Okay.
Remember, the player needs to collide with the tiles in that layer because it contains...
He's currently
walls.
explaining this
So we are
part.
getting its tile map ID right now so that we can later check for collisions against this layer when the player is trying to move. So now for the movement, we need to add the step event. Let's go up here, click on the plus sign, then go under step and select the step event. The step event will show up here just below the create event. Let's add some code here to check for input from the WASD keys and store them into two variables, one for horizontal input and one for vertical. The first variable here, which is...
Wait a minute. I don't know how important this is, but I'm hoping this fixes it. He's using capital letters. If that's all I need to do... Huh? Just to make sure. Alright. Close that. Open this. Thank goodness. Anyway, this... Alright, so everything is working. Oh, I can even go up here. It's a very tight squeeze. And I'm not very fast. I might add something. I might try and add something for you to be able to move faster, like a dodge roll. That would... It wouldn't really have an animation. It would probably just be you in a ball. It wouldn't have an animation. But, yeah. Okay. I can hear it. So, we can move on from that step. We might, at this rate, we might even be able to finish the first episode of the tutorial. Yeah. Oh, and hi, Mom.
That gives us 1 when D is held down and -1 when A is held down. But you're probably wondering, why is it that way? See, the reason we are doing this is because in GameMaker, if you want an instance to move to the right, you add 1 to its X position or its horizontal coordinate.
Okay. Well, it might be better. Capture any full screen application. Nah, capture specific window. Or, I think... How did I get it to capture... Display capture, that's... Nope, wrong thing. And then that, the game capture. I can just move this out of frame, but for right now, I think that it might be best to have this on screen to some extent, because this is a video I'm actually watching. That way I can have this on screen, I can be looking at chat, and I can be coding stuff.
And to move left, you subtract 1. That's why we have these variables set up in this way. Similarly, for the vertical input, what we're gonna do is we're gonna subtract the input from W from the input of S. So that gives us 1 if S is pressed, which helps us move down, and -1 if W is pressed, which helps us move up. Now we know how much to move on both the X and Y axes, so let's actually call a function to help us move. The function we're gonna call is move and collide. A function in GameMaker takes parameters that determine how the function is going to work. For the move and collide function, it takes 3 main parameters. So that's how much to move on the x-axis, which is horizontal, how much to move on the y-axis, which is vertical, and which object or tile map to use as walls so it stops when that is encountered. So let's write this for our code. This calls the move and collide function with the x value being the horizontal input from the keyboard multiplied by the movement speed. Then the y value is the vertical input from the keyboard multiplied by the movement speed again. And then the collision check being the tile map that we stored earlier. So the player is going to try to move and it will be stopped by any tiles in the tiles called layer. If you run the game now by pressing F5, you'll be able to move the player in any direction using the WASD keys. that it's using the same sprite for all directions. But you know we have 8 sprites to use for this. So now we're gonna implement that. We're gonna do this using conditions. A condition lets you run some code only if that condition is true. The way we're gonna do it is this. If the player is moving, then we check the input.
Your emotional support.
Based on the input, we set a walking sprite. Else, if the player is not moving, then we set an idle sprite depending on which walking sprite was being used. So let's add this code.
Oh, that's. If.
First of all, we have a grouped condition that checks if the horizontal input is not 0 or the vertical input is not 0. This means that if either of these conditions is true, the code after it will run. And overall, this grouped condition means that there is input and the player is moving. So let's make a block for this. Any lines that you have inside this block are going to run when the condition is true. In the block, let's add another condition. This checks if the vertical input is greater than 0, meaning we are moving down. So in that case, we'll set the sprite to the walk down sprite. This way we're gonna add 3 more conditions for the 3 other directions. So else if vertical is smaller than 0, it means we are moving up and we use the walk up sprite. Else if horizontal is greater than 0, we are walking right, so we use that sprite. Else if horizontal is smaller than 0, then we are walking left, so we use that sprite.
One moment. Okay. If. Boom. Boom. Is greater 0. Then we go over to this sprite and get ourselves a soda. One moment. SPR underscore player walk down. Else if. Actually, wait a minute. I don't know. Yeah, now I'm thinking like a programmer. Oh. Player walk up, right, and left. And then refer is okay. Just need wait, no. Need to put that there. And that goes there. That goes from down to up. This goes from down to right. And this goes from down to left.
So it's all simple logic. It might be a little intimidating if you're new to coding, but just think of it as talking to the computer, asking it, hey, is this variable this value? And then telling it what to do in that case.
So basically asking it yes or no questions, and then if yes, do this. If no, do something else.
Some time to read this code and make sure you understand what is happening. Now let's add another else block here. This will run if the condition over here is false. So if this block means that the player is moving, this block means that the player is not moving. So here we're gonna set an idle sprite based on the walking sprite that was being used. Let's add a check if the current sprite is equal to the walk right sprite.
Okay. So it is if not that. Not that either. Shift sprite underscore index equals for some reason. I'm not going to question that in fear that my computer will explode if I do. Player walk right. Oh, in that case, I just copy, paste.
In that case, we set the sprite to the idle right sprite.
Okay, so right. Underscore index equals SPR underscore player idle right.
So using the same logic, let's add 3 more conditions. Let's check if the sprite is walk left.
And alright. If it's not broken, don't fix it. Copy paste it. Oh gosh. Boom, boom. Okay. There. Aha. Wait, what? Oh. That's right there. I need another one of those. And then I should only... Oh, I need else's in front of this. I don't think it matters what order I do these in. Up, down, left, right. Up, B, start. But, yeah. And then else. Oops. If, let's see. Left. Left. Okay. Everything seems to be checking out. We go up, and then up. If we're down, we do down.
Then set it to idle left. If it's walk up, we set it to idle up. And if it's walk down, we set it to idle down. Again, this might be a lot if you're new, but if you stop to look at it and try to understand the logic, it's actually pretty straightforward. Also, if you're wondering why we've used 2 equal signs here but 1 here, it's because you use 2 equal signs when comparing 2 values in an if condition, but you use 1 equal sign when setting the value of a variable.
Oh.
So now run the game by pressing F5.
So wait, this is... are these two equal? And this is... this equals this. Set this to this. Okay. Now then, let's see. Wait a minute. I have up and down good. I forgot to make my verticals up here horizontal, didn't I? Yeah. And then whore. Yeah, there we go. That should be it. There we are. Okay. I'm going to do something risky, something that the person does not say I should do, did not tell me to do. Let's see. Key pressed. Space. Oh gosh. One moment. Move speed equals 3. Alarm set. One 0, or is it like 60? Then let's see, how do I make it so that, okay, there's still something. Yes. Alright, move speed. So do I just do this? Is that unidentified? Set alarm. This is an alarm array directly. So what exact? Oh yeah, sorry. Yep, everything here is all right. Let's see. I don't feel any faster. So then, one moment. Let me get rid of this. Delete event. Yep. Place it right here. I'm trying to rack my brain. Keyboard check pressed. I need. Oh, I need spacebar, and there's no space. I'll just set it to R for now. And then I don't really know what this ORD does, so I'll add it just to be sure. Keyboard check. Okay. Let's say var underscore role equals QHS press or All right. If I go here and type in if underscore role is over 0, all right. Move speed equals 3. Let's see if this works. Yeah, I am zooming. Oh. Oh. I am faced with the consequences of my actions. Oh gosh. So wait, this lets me, yeah, it lets me clip into walls if I'm not careful. All right, noted. Let's see. Anyway, I'm gonna hold on to that for later. I want to set an alarm eventually that will turn this off in like after like half a second, so it gives you a burst of speed, but you like have a second cooldown and stuff. But yeah, I'm proud that I was able to make that much with just copying that.
And you're gonna see that the player moves and animates with the correct sprite for where it's moving and whether it's moving. Now there is a quick fix I want to apply. If you slide along a wall, you can see that the movement gets a little jittery. So to fix that, we need to apply limits to how much the player can move in any given frame. So let's go to the step event and go to this move and collide call, and we're gonna add some more parameters. We want the next 3 parameters to use their default value, so I'll just enter undefined 3 times.
All right.
And now
Let me go up here and then comma undefined, comma undefined, comma undefined. Boom.
now we have come to the parameters that we actually want to set. So the first one is the horizontal limit. I'll set that to move speed. And then we have the vertical limit, which I'll also make the move speed.
Okay. Sounds easy enough and doesn't utterly destroy my thing that I just created. Move underscore speed and then another, oh wait, there. Move underscore speed. There we go.
slide along the walls, you'll see it's now very smooth.
Let's see if that also fixes my wall clipping glitch. Nice. Anyway. Oh, right. I deactivated that code. Completely forgot. This might actually be nice as sort of a dev tool to help me get around the map faster. So I'm just going to leave it on. Assuming that it doesn't make me clip into walls. It would appear that it still can make me clip into walls. Oh wait, what the? Oh, interesting. Wait. Interesting. One moment. Alright. Wait. That's interesting. Okay, so I don't clip into the top and bottoms of walls. However, I do clip into the sides. And oh, wait. That's your issue right there. I'm clipped into a wall, and then if I do that, still clipped into a wall, but if I do this, suddenly I'm not clipped into a wall, and it updates and so when I go this direction, it updates the oh, that's neat. Okay, so when it changes the sprite, because this sprite is flat, this sprite is whiter, it clips in when it changes the sprite. Okay. In that case, I wonder if my move speed has anything to do with it then. Like if I just boot it up normally, go over here. Yeah. If anything, it makes it easier to get at. Because then I can just leave through there. But I can't normally because I don't have enough speed. That's really cool that I was able to figure out how that bug was doing. Meaning I'd have to change the art and the sprites in order to get rid of that. I'd have to make him a uniform width. But that's really cool. Anyway, I'm going to keep that for right now. Enemies.
Now we are in the second half of the video and we're gonna add enemies to our game. They're gonna move around randomly in a rectangle surrounding where they were created, and they're gonna follow the player when it's near. Our game's gonna have two types of enemies, so we want a way to give both of them the same code from the same place. We're gonna do that through parenting. There will be a object called obj enemy parent. This will have all the code for how enemies move and behave. Then we're gonna make objects called obj enemy 1 and obj enemy 2. These will be children of the main object. This way they will use the code from their parent. If the parent has any properties like how much damage an enemy does, then these child objects can have their own values for those properties so that the child objects are unique. They would still use the same code, just their variables would have different values. So let's make an object and call this
Okay. Object create and call it what? Obj underscore what is it?
obj
Enemy?
enemy parent.
Alright. Obj enemy underscore parent.
Then let's make an object called obj enemy 1. This
Okay. Wait, what? Object 3. Strange. Oh well. It would be obj underscore enemy underscore 1.
This will be our first enemy, and we'll make the second enemy in a later video. While you have your obj enemy 1 open, go here in the inspector and click here to give it a sprite. Make sure it's the enemy 1 sprite.
Gosh, workspace. Huh. Oh, this is still the room inspector. Object. Oh, there we are. No sprite. Sprites. Give it the small little demon enemy thing.
Then go down here and open the parent menu. From here we need to set a parent, so click here.
Go over. There were parents. Object parents is enemy parent. Nice.
Then select obj enemy parent, so it knows that it's a child of that object. Let's open the room now and place some enemies here. In the layers panel, make sure the
Instance. Obj enemy 1. Let's zoom in. Alright. I hope this is easier for you to see than it is for me, because it is not very easy for me to see where I'm placing all these guys. Okay, I think that's going to be enough.
instances layer is selected, and then from the assets list, drag and drop some enemy instances into the room. Now let's code our enemy so it walks around and follows the player when it's near. Let's double click on obj enemy parent. Before adding any events, let's set up some properties. So go into the inspector on the left, and at the bottom, let's click on add variable.
One moment. Get rid of that. Add variable.
To add our first variable to this object. The first variable will be HP, which is the amount of health that this enemy has. I'll set this to 3. Then let's create another variable called damage. This is how much damage it does to the player. I'll set it to 1. Then let's create a variable called
Damage. I'm gonna live forever.
distance to player.
Oh, that's a long one. underscore 2 underscore.
This is how far the player has to be for the enemy to start following the player. So let's set it to 80, which would be in pixels. So that's 80 pixels. Then let's make a variable called move speed, which is how fast this enemy moves. Now it's time to code our events. First of all, I'm gonna go and add the create event to initialize some properties. Let's add this code here. These are the target coordinates that the enemy is going to follow. So it's the target X and target Y. Right now it's set to the same coordinates as the enemy. Then we are setting alarm 0 to 60. There's an event called alarm 0. So what this means is that the
in that case, if I do this at alarm 0 equals 30, mine's a different color than his, so I'm assuming that they can't be. Can they not be the same? It isn't showing anything. Let's see, alarm 0. Alright. And all I need to do is move speed equals 1. And then let me see if that's all I need. Yeah. It's more so a rush than anything. But yeah, that's really cool that I just made rush. Yeah. Anyway, sorry, I have to do something so it's not just me following the tutorial.
alarm 0 event will run 60 frames after this line is called. And by default, 60 frames is 1 second. What we want is for alarm 0 to run every second, and every second the enemy sets a new target position for it to move towards. So we are gonna work on that as well. For now we need another line in this event. We are getting the tile map of the tiles called layer again, which we did in the player as well, so that the enemy can also
Excuse me. There. Pretty sure that's right. That's how I did it. Yes. Because there's right there. Okay.
check for
Oh, no, it is a capital T.
Let's program the alarm zero event where we're gonna set a new target position for the enemy. I'll click on the plus sign here and under alarm, I'll select the alarm zero event.
Mm-hmm.
Here we want to do this. First of all, we're gonna check if the player exists and if the player is close enough. If so, we'll set the target position to the player's position so the enemy follows the player. Else, if that is not true, meaning that the player either doesn't exist or the player is not close enough, then we're going to set the target position to a random point in a square area around the enemy. So let's write the conditions for the first check: if the player exists and if the distance to obj player.
Alright. If in underscore player and in this there. OBJ player
Is less than distance to player.
is less than distance to play. Oh goodness.
We're gonna set the target at
Finally a new line, because lines are awful. Alright,
X
next.
and target by values to the player.
Alright. Target X. Target Y. Oh. Okay. Equals and then equals OBJ player and then OBJ player period X period Y.
Players X and Y values. Then we add an else block, and here I'll first of all set the target X variable to a random value between two numbers. The first
And then else random range.
number is the starting X position of the enemy, -100.
100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100. 100 X start minus 100. Get out some things there. And then
The second number gives a starting X position.
okay, that makes sense. Starting X position plus 100.
Of the enemy plus 100.
Oh,
So the target X will be anywhere between these 2 points using the position that the enemy started at. Then we're gonna do the same for the target Y position.
alright. In that case, copy, paste, Y.
But using the Y start position of the enemy. Finally, we need to set alarm 0 again so that it runs again after 1 second, and this forms a loop so that alarm 0 keeps running every.
And then alarm 0 equals 60. Oh, wrong kind of brackets. There we are.
Second. Now we want to allow the enemy to move towards the target, which we'll do in the step event, so I'll go and add that. Here let's figure out how much we need to move horizontally and vertically by adding this. For the horizontal value,
Okay. Var slash core equal lamp. Oh wait.
I'll take the difference between the target X and the current X.
Minus X.
And then to make sure that it doesn't go above 1 or below.
Minus 1. And then 1.
Low minus 1, I'll clamp it to the range between those values. So it will be between minus 1 and 1. Then I'll do the same for vertical, but using the.
Okay. And then, of course, our good friend, copy paste for, and that's just Y. That's also Y.
The target Y and current Y values.
Yep. Everything looks
Finally,
right.
we'll call the move and collide function with the horizontal and vertical values multiple.
Right. Move and collide plus move speed underscore speed and then ver that's not a plus, that's multiplier. Honestly, I kind of wonder what would happen if I did put in a plus.
Multiplied with the move speed. It should also stop.
Alright, boom, and then
When it collides with the time map.
tile map. Boom.
Now run the game with F5. You will see the enemies moving above.
Did I do something wrong? Abort. Let's see. Try again. Yeah. Enemy parent. Not set before reading it. One.
Spawn randomly, and when you get close enough, they start following you. Once you get multiple enemies to follow you, you'll notice that they all end up overlapping each other, and it just looks like it's one enemy, so we need to fix that.
So then, apparently it's something with alarm 0. So I'll have to go back a bit.
I'll go and add that. Here, let's figure out.
Let's see if instance OBG player. Distance to player. Let's see, what exactly is it? Distance to player. Oh, I must have. Yeah, it's one of those variables. Distant. Oh gosh. Yeah. Boom. Okay, I just made a typo. And it isn't crashing now, so perfect. Alright, now then. I should make some of these hallways slightly wider. Also, move speed is set to 0, so I'm going to set it to 1, and then they'll be able to move. Okay. Yeah. Oh, and they'll try and return to their home place of origin. That's cool. Yeah, I really need to have it be a larger areas. Anyway, this is the collision. Let me just move that out of the way. Draw some more. There. And then how do I erase stuff? Boom. Boom. Alright. Oh, wait. And then just put that there. Tiles back. Just there. Should feel slightly less claustrophobic in the areas where I don't really want claustrophobia. Yeah. Yeah. Okay.
How much we need to move horizontally and vertically by adding this. For the horizontal value, alphas will stay in their own place.
Oh, wait.
So collides with other enemy instances. For that, alphas will make this parameter an array by adding square brackets. An array is just a value that contains multiple values. So I'll add a second value into this array, which is the obj enemy parent object. Now this function is going to make the enemy stop when it collides with either the tile map or any other enemy instance. So
I wasn't really seeing that, but let's I fixed a bug that is in this. Yeah, see, they aren't going to
run the game and get multiple enemies to follow you. You'll see that they don't overlap anymore and they stay in their own place. The
depth
final
order.
thing we'll do for this video is to make sure that the order in which our instances are drawn follows the vertical positions of the instances. For example, if the player is below the enemy, it should be drawn in front of it, but if it's above the enemy, then it should be drawn behind it, otherwise you know it's not going to look correct. For that, let's open the obj player object. I'm gonna go to add a new event, and under step, I'll select the end step event. This is the same as the step event, but it just runs after the main step event. So it will run after every instance has run its step event and has moved to its new position. Here we're gonna make a with all block. What this means is that anything inside this block is going to run for all instances in the room. So that's the player and all enemies and everything else. So in this block, let's set the depth variable to negative bbox underscore bottom. The bbox bottom value is the vertical position of the instance at its bottom edge. So we want to use that to sort the instances. It's set to negative because a lower depth means the instance is drawn on top. So if you are below another instance, meaning your vertical position is greater, your depth is going to be that much lower, so you are drawn above that other instance. If you now run the game and walk around an enemy, you'll notice how the drawing order is switching correctly and it now looks the way it should compared to how it looked before without the depth code that we just added. And that's it for this video. You now have a working player that moves and animates, and enemies that move randomly and follow the player when it's near. We're now gonna move on to combat, which can either be real-time sword combat or turn-based combat. So click on the video that you want to follow and
Wow, interesting. Such a array of options. I'm joking, of course. The videos are actually out. It's just that when it's windowed like this, I can't do it. So, do we want to try real-time combat where I just swing around a sword in the room and deal damage to them, or do I want to make it turn-based where we get drawn in, where if I come into contact with these guys, I get brought to a second room and we duke it out through I don't know, a game of Tetris. I have looked at each of them. It's mainly just press the button, charge up your super, and then press the super button. Turn-based. Okay. Turn-based battle.
hi, in the last part of making our RPG, we made a player that moves and animates, and enemies that move around the room and follow the player. In this video, we're gonna make it so when you touch an enemy, a turn-based battle begins, so it goes into a different room to start that battle.
How do I, not full screen, window this? Theater mode? No. Oh, there. Boom.
From there, you can do attacks to hub. Hi, in the last part of making our RPG, we made a player that moves and animates, and enemies that move around the room and follow the player. In this video, we're gonna make it so when you touch an enemy, a turn-based battle begins, so it goes into a different room to start that battle. And from there, you can do attacks get started. I divided this video into separate sections, and in the first section, we're gonna design our battle screen, which will be its own room, and make a switching loop so you can touch an enemy to go into battle, and then press the exit button to come back. In the project, if you open the sprites folder, you'll see a folder for turn-based sprites. These are the sprites we're gonna use in this video. There is a background for the battle screen, then a button for heavy attack, a button for light attack.
Let me go to workspace sprites. Oh yeah, turn-based battle. Here we are. Battle screen, button heavy, button light, button run. Okay.
Attack, and a button for running away from the battle. It's time to make the objects now. I'm gonna right click on the objects folder and create a new group. I'll call this battle, so this will have all the objects that we need for the battle. I'll go ahead.
Wait, he's doing
First object
what?
in this folder. I'll call this OB. I'm gonna right click on the objects folder and create a new group. I'll call this battle, so this will have all the objects that we need for the battle. I'll go and make the first object in this folder. I'll call this OBJ battle switcher. I'm gonna use this object for switching from the game room into the battle room.
Okay, well, let me figure out how to create group. There we are. And then this would be bat. Let me increase the size of that so it's easier to see. And yeah, it's still in HD for some reason. Is it smaller than before? I don't know. Oh well. That looks like how you spell battle to me, unless I'm blind.
So this object will carry information from the first room into the second room. Open.
Objects. What?
The object, and in the inspector, under its properties, enable the persistent option. So this object
OBJ battle switcher. That's what he wants me to call this. Oh wait, no. Lowercase o. It's just easier if everything that can be lowercase is lowercase. Battle switcher.
will carry information from the first room into the second room. Open the object, and in the inspector, under its properties, enable the persistent option. We need this because by default, when you change the room, all the instances in the first room are destroyed. But we need this object's instance to carry over into the second room, and enabling the persistent option will allow us to do that. Then let's make another object in the battle folder. I'll call this OBJ battle manager. So this will be the object managing the battle loop and turns in the battle. Now it's time to make the buttons, but for them we need a parent object so we can give all of them the same code. I'll make an object called OBJ action parent. Then I'll go and make 3 more objects. First of all, OBJ action light for the light attack. Go and give it the sprite a battle manager. So this will be the object managing the battle loop and turns in the battle. Now it's time to make the buttons, but for them we need a parent object so you can give all of them the same code. I'll make
Which would just make everything easier. And then create new object OBJ bat
an object called OBJ action parent.
oh
Then I'll go and make 3 more objects. First of all,
Mm-hmm. O. Alright. O. J. And then no sprite, give it sprite. That way it's carbonated. Light button.
In the parent menu, set its parent to obj action parent. Then I'll duplicate this object with Control D and call this obj action heavy for the heavy attack, and then double click on it to open it. I'll give it the sprite it needs.
And then we basically do everything the same, just with the heavy attack. And I'm assuming we do the same with the running away attack. Is that how you spell heavy, or is there an A in it? I think there's an A in it. Heavy. Okay, and then sprite, turn-based, sprite button. Parents. Battle. Action parent.
It already has the parent set because we duplicated it. I'll then duplicate this object again with Control D.
Oh, wait, what? Control D. Oh. Undo. Run.
And call this obj action run, which is for running away. And then double click on it to open it. I'll give it the sprite it needs in the inspector. We're gonna create our battle screen now. For this, let's go in the rooms folder, and here we're gonna make a new room asset. I'll name this rm_battle. Let's double click on it.
Now we need a new room.
In the inspector, let's set the size of the room to 320
Boom. And then in the inspector,
by 180, which is the size of our camera in the game. In the layers panel, open the background layer and set the sprites to the battle background from the turn-based folder. That's done.
and then in the background layer, one moment, I didn't quite catch that.
Which is the size of our camera in the game. In the layers panel, open the background layer and set the sprites to the battle background from the turn-based. Let's set the size of the room to 320 by 180, which is the size of our camera in the game. In the layers panel, open the background layer and set the
Boom. No, that's There we go.
That's done, so let's open the instances layer and add some instances here.
Instances. Oh wait, what?
From the objects list in the assets, drag and drop OBJ Battle Manager into the loop. Then drag the buttons one by one and place them wherever you want. You can disable the grid by clicking here, so you can place them wherever you want.
There we go. Okay. Alright. Ooh, that's gonna be a lot of tabs, I just realized. Run, where do I, oh, there. Yeah, I think that's good enough.
I'll set them up this way, so it's the light attack first, then heavy, and then the run one. Okay, that was a lot of setup, but we can finally start coding now. The first thing we're gonna code is switching between the game room and the battle room. We're gonna start by coding what happens when the player touches an enemy. I'm gonna close the room tab and from the assets, open OBJ player.
OBG player. Not rooms, right? OBG player is in sprites for some reason. Just gonna drag him out. Go into OBG player.
In the events list, let's go and add a collision event with OBJ enemy parent. This runs when the player touches any enemy instance. Here we just want to create an instance of the switcher object and give it the information it needs to carry into the battle room. The first thing we're gonna do is check if the switcher instance already exists. If
0, 0, 0. OBJ battle switcher.
called player data, which is the player itself. So it will have all the variables that the player has.
There. And then switcher dot
The second is the enemy data. That's the other instance that you're colliding with. So through that, we can access all the variables of the enemy that you just touched. Both of these are structs, which are just collections of variables.
Mm-hmm.
Then the final variable is the original room, which is the current room, so that at the end of the battle, we know which room we want to go.
Switcher dot underscore room equals room. Oh wait, wrong. There.
Now go back to, and now we're gonna call this function to change the room to the rm underscore battle room that we created. With this, we
Okay. Room underscore go to RM battle. Boom. Oh wait.
covered going
Wrong.
into the battle room, and now we're gonna program the action buttons so that we can press the run button to exit the battle room and come back to the original room. Let's first open obj action parent to program the base behavior for the action buttons. I'm gonna add the create event here, and in the event, I'm gonna make a function called action, and this will be an empty function for now. So using this syntax, you can create your own function.
Okay, one moment.
Your own functions, and in the event I'm gonna make a the room to the rm underscore battle room that we created. With this, we have covered going into the battle room, and now we're gonna program the action buttons so that we can press the run button to exit the battle room and come back to the original room. Let's first open obj action
Parent.
parent to program the base behavior for the action buttons. I'm gonna add the create event here, and in the event I'm gonna make a function called action, and this will be an empty function for now. So using this syntax, you can
Left press.
Program the run button. So go into obj action run. You're gonna see the create event here from the parent, and we want to.
Okay, and then go into U. Am I? No, not on U yet. There we go.
Override it. So go into this menu and select override events. Here let's make the action function again, and this time the function is gonna have something inside it. It's simply gonna change the room to go back to the original room. So it's calling the room goto function, and then the room it's switching to is taken.
Action function. Boom. Oh, it's done. No. Boom. Boom. Room. Go to obj underscore. I have a bad feeling about this.
From the switcher object using the original underscore room variable. Remember we set this variable before in the player, and now we are using it to go back. Now there's just one thing. When we create the switcher instance in the player, it's gonna go into the battle room, and then we come back with the exit button, but the switcher is gonna continue to exist forever. That means you can't go into the battle ever again. So what we're gonna do is we're gonna destroy the switcher instance when we come back into the original game room from a battle, but we're gonna do it 1 second after we have come back. So that gives the player a second to run away from the enemy, because during that second the battle won't be triggered again. So in the assets, let's go into obj battle switcher. Here let's add an event. Under other, I'll add the room start event.
Battle switcher. Room start event.
This event runs whenever a new room has started. Let's add a condition to make sure that this is not the battle room, so it only triggers for game rooms. In that case, I'll set alarm 0 to 60. Let's add the alarm 0 event now.
That's the wrong thing. RM underscore battle. And alarm 0 equals 60. Boom.
Now, here I'll simply destroy the instance. So when the switcher comes back into a game room, 1 second later, it will be destroyed. Now we can finally run the game and test this. Go near an enemy, touch it, and the battle begins. Click on the run button, and you're back in the original room.
Oh, so we're already capable of testing things. Okay, boom. I'm not here, neither is the... Oh. That didn't happen like I think it should, but alright.
The problem now is that the game room has restarted. It has forgotten where we were when the battle started. To fix that, go back into GameMaker and click on your game room. Which for me is room 1. Go into the properties and enable the persistent option. This way it will remember where everything was when you leave the room and come back. So now in the game, if you start a battle and come back, you
I can juke him. I'm. Oh no. Wait. Wait. Hmm?
Where you were when the battle began. Let's take some time to take a breath now and move on to the next.
Okay. I think after this video, which we're about, let's see, is that a third of the way through? I think I'm going to be done after this video for this week.
Next section.
This is fun. I'm making
In this
progress.
section, we're gonna display the player and the enemy on the battle screen and give them health bars so their health properly appears on the screen. We need two more objects for this, which are the instances for where the player will stand and where the enemy will stand in the battle room. So I'll make a new object and name this obj battle player.
New object. I've accomplished a log. Well, you know. It's not easy, but it's hardwood. I don't. I was trying to figure out how to make a lumberjack joke and failed. Anyway, what am I supposed to be naming this thing again? OBJ underscore bat battle player.
I'll go into the inspector and give this the player sprite for when it's standing idle facing right. Then I'll make another object and name this obj battle enemy. I'll go in the inspector.
Create another object. This one is obj underscore bats. Oh gosh, I can't do spaces. Battle enemy.
And give this the sprite for the NPC, because in the game this will just take the sprite of whichever enemy you're fighting, so the sprite you select here doesn't really matter. I'll open the RM battle room and place both of these objects. I'll put the player on the left and the enemy on the right, and then I'll
Alright, cancel that.
close the. Let's go into obj player and open the create event.
Another OBG battle player? No, OBG player.
Here I'm gonna make a few variables. We have HP, which is how much health the player has. Then we have HP total, which is how much total health the player can have. Then we have the amount of damage the player does to enemies, and then a charge variable.
Okay, so it wants HP. Zero.
Which will be used for the heavy attack. Now let's go into obj enemy parent. In the create event, let's make a variable total
Wait.
health of the enemy.
Go
Then
where
make a
and do what?
variable for the amount of damage the player does to enemies, and then a charge variable which will be used for the heavy attack. Now let's go into obj enemy parent.
Alright.
In the create event, let's make a variable for HP total. That's the total health of the enemy taken from its starting HP. Now we want to pull this information from these instances into their battle instances. So let's first go into obj battle. From its starting HP. Now we want to pull this information from these instances into their battle instances. So let's first go into obj battle player. Here I'm gonna add the create event. I'm gonna make a variable for the data of the player.
Wait. OBG battle player.
Here I'm gonna add the create event. I'm gonna make a variable for the data of the player. It's just pulling the player data struct from the switcher so that it's faster to write. Then I'll go into the
OBJ. Battle switcher. Oh, right. I saw my mouse moving over here because of how I have the screen, and I thought someone sent something in the chat.
obj battle enemy object. I'm gonna add the create event here. Here also I'm gonna make a data variable and this will pull the enemy data struct from the switcher. Then we're gonna set the sprite of this instance from the sprite in the data struct. So it's taking the sprite that the enemy had in the game room and applying it to the instance in the battle room. Now we have the data struct for both the player and the enemy, so we can read the health information from it and draw it on the screen.
Okay, one moment.
HP. Now
Real
we want
fast.
to pull this information from these instances into their battle instances. So let's first go into obj battle player. Here I'm gonna add the create event. I'm gonna make a variable for the data of the player. It's just pulling the player data
Yeah, there we are. I thought I may have missed that.
struct from the switcher so
Oh, and
that
then
it's faster to write. Then I'll go into the obj battle enemy object. I'm gonna add the create event here. Here also I'm gonna make a data variable, and this will pull the enemy data struct from the switcher. Then we're gonna set the sprite of this instance from the sprite in the data struct. So it's taking the sprite that the enemy had in the game room and applying it to the instance in the battle. Now we have the data struct for both the player and the enemy, so we can read the health information from it and draw it on the screen. Let's do that for the enemy first because we are here already. I'm gonna go into the events and under draw add the main draw event. This is where you can draw anything in the. Now when you add a draw event, the
was going. I was trying to go in.
Position where the health bar will be drawn. At the Y position,
There.
then the
Goodness, how many of these are you gonna make me do?
width of the health bar.
440.
And then its height. The way we're gonna draw a health bar is by taking this SPR box sprite, which has 9 slicing enabled, so you can stretch it as much as you want and it will retain its corners. So we're gonna stretch it first to make the base of the bar, which is the total HP, and then stretch it again to draw how much health the player or the enemy currently has. For the base of the bar, that's called draw sprite stretched. We are drawing SPR box, its first frame with the X, Y.
And now we just need to put in all of our. I'm guessing this also goes.
By width and height we created. Then we call another function, but this time the one that allows us to color it. This time we are drawing the
Oh, one moment. EXT. Alright.
second frame, so this will be
Box. 1.
one. Then the X and the Y are the same, and then
The X and the Y are the same.
for the width,
Mm-hmm.
we are taking the width variable.
Alright. Is that a... Let me see, is that it real fast? Yeah, that's a multiplying symbol. Alright. Oh, wait, no, there. There. Another... Data.
And
Dot HP.
multiplying it with the HP from the data.
Oh my goodness. Okay. Then we have the height. And the color is C underscore red. Oh, I forgot to add in my boom. There. What is there?
which is red for the enemy, and then the opacity, which will keep.
So then we need the opacity, which is 1.
At 1. Now we want to do this exact same thing in the player, just with a different color. So let's select all of this code.
Oh, thank you. Control V. I mean Control C. Gosh. if I oh gosh.
And copy it with Control C. Let's
Gosh.
go into OBJ Battle Player. Here, let's add the draw event. And in the event, I'm gonna paste the code with Control V. The only thing we'll change here is the color in this function call from C red to C green. Now run the game and go into battle. You'll see the correct sprite for the enemy here, and you can see the health bar for both the player and the enemy. We are now gonna work on allowing you to click on the light attack button and attacking the enemy, and allowing the enemy to attack you, and then make a loop out of that. We're gonna program the whole turn system now. So for that, go into OBJ Battle Manager. Here I'm gonna add the create event and set up a few variables. This variable will be 0 when it's the player's turn and 1 when it's the enemy's turn. This variable stores how
Alright, not there.
how much damage to do to the enemy during the player's turn after its attack animation is over. We are creating a function which will be called when the player wants to attack. It takes one parameter, which is how much damage this attack will do. In the function, we are storing that damage value in the damage to enemy. Enemy variable.
Underscore damage.
And we are setting enemy turn to 1 because the player's turn is over.
am coming up with ideas on how to
and
do stuff.
subtract the damage from its health. Then I'll set alarm 1 to 60. That's where the enemy attack will happen. So let's go and add that alarm 1 event. Here first of all we're gonna calculate how much damage the enemy will do. This will be the damage of the enemy from its data struct, multiplied with a random value between 0.7 and 1.2. So the damage the enemy does will vary a little every time it attacks. Then we take the health of the player from its data struct and subtract the damage. Which from it. And now we set the enemy turn variable to 0 because the enemy has attacked and it's the player's turn again. The turn system is set up now, so we want to allow the player to click on the light attack button, which we'll call this function. We also want to disable the player's buttons if it's the enemy's turn. For that, let's go into obj action parent and here add the step event. Let's do a simple check. If it's the enemy's turn, then we'll set the alpha or opacity of the buttons to 0.2. So they are
Zero point two.
appear a little transparent. Otherwise, if it's the player's turn, the alpha will be set back to 1, so they are fully visible. that if it is the enemy's turn, you can't use the buttons. Now let's allow the player to click on the light attack button and do an attack. Open the obj action light object, and in the events, we want to override the create event from the parent like we did in the run object. And now let's add the action function here. This will call the player attack function from the manager object. If you remember, this function takes a parameter, which is the amount of damage done to the enemy. For that, we're gonna take the damage from the player's data struct. That's it for the turn.
Let me check that again.
That's it for the turns.
Hmm. Dang it. Let me go back to.
We're gonna program the whole turn system now. So for that, go into obj battle manager. Here I'm gonna add the create event and set up a few variables. This
Okay.
variable will be 0 when it's the player's turn and 1 when it's the enemy's turn. This variable stores how much damage to do to the enemy during the player's turn.
Oh wait, I just. Oh my goodness. There. Noise. I think I see a problem. One moment.
After its attack animation is over,
Let me just
we are creating a function
skip
which
to
will
the
be
end.
game and go into battle. You can now click on the light attack to attack, and the enemy's health goes down. Then the enemy does an attack, and the player's health goes down, and then you can click on attack again, and the loop goes on and on. Now, even if you empty the enemy's health, nothing happens, and at this point, the match should end. So let's work on that. Let's go into the obj battle manager.
Wait, what?
Is that or below?
I didn't realize there were vertical lines on. I mean, then again, they're just L's, but.
Zero. Because you will agree in either case the match is over and the function will return true. Now let's go into alarm 0. This is where the player attacks and then we set alarm 1 for the enemy's attack. I'm gonna remove this and make it be based on a condition. We're gonna check if the match has ended, and in that case we're gonna set alarm 2. That's where we're gonna
One minute. 60.
go back to the original room. Otherwise, we set alarm 1 as before.
There.
So the enemy can continue to attack. Now let's open alarm 1 where the enemy attacks. After it has attacked, we're gonna do a check to see if the match has ended. And in that case, we're gonna set alarm 2. Now let's go into the events and add that
And add alarm 2.
alarm 2 event. Here we are simply gonna switch back to the original room just like we did in the run-on.
Alright. Room. Go to. Slash go to. OBJ.
Object.
Switcher.
This will send us back
Dot. Original room.
back into the original game room where we can do something based on the health of the player or the enemy. So for the player, let's
I'm going to test this real fast. Nice. Hmm. I can't really do anything from out here. Nothing that I think would be useful. However, I could potentially lure all of these guys someplace that I could take advantage of. Yeah, that guy could get stuck in that corner. Don't really know what that would accomplish, but yeah. I'm just gonna... Collide. How do I zoom over to... Edit the arrow keys? It wasn't that. That's how I move up and down vertically. How do I move horizontally? Does that make sense? Now let's see. That should... Oh. Instances... Where... You right there. Okay. Nothing. Yeah. Nice. It's like a invisible wall. One moment. You see, this loops really nicely, but these... These don't. Oh well. I guess I just won't let it bother me. Or at least try not to. Anyway. Need to go to over this.
Go into OBJ player. Let's open the step event. Here let's do a simple check to see if the health is at or below 0.
Oh, just OBG's player. Go to the step event. You know, on top of everything else that's in the step event. Let's see if... is less than or equal to 0.
At or below 0. And if it is, we're gonna restart the game. For the enemy, let's go into OBJ enemy parent. Let's open the step
OBG enemy parent? There.
Here we'll do a similar check to see if the health is at or below 0, and in that case, we'll destroy the enemy instance. That's it for that, so run the game, go into battle.
If HP is below or equals 0, how exactly do I do that? Instance destroy. There.
Destroy the enemy instance. That's it for that, so run the game, go in.
Wait. Did I? Dang it. Where else? Okay. Apparently nothing else is bugged at the moment. Alright. Nice. Let's see. I still can't enter more than one fight.
Go into battle, fight the enemy and lower its health. When you've defeated it, you'll come back to the room and the enemy will have disappeared. So with this, our turn.
Wait.
The battle screen, then a button for heavy attack, a button for light attack, and a button for running away from the battle. It's time to make. We're gonna create our battle screen now. For this, let's go in the rooms folder, and here we're gonna make a new room asset. I'll name this rm_battle. Let's double click on it and open it. In the inspector, let's set the size of the room to 320 by 180, which is the size of our camera in the game. In the layers panel, open the background layer and set the sprites to the battle background from the turn-based folder. That's done, so let's open the instances layer and add some instances here. From the objects list in the assets, drag and drop OBJ Battle Manager into the room. Let's drag the buttons one by one and place them wherever you want. You can disable the grid by clicking here, so you can place them wherever you want. I'll set them up this way, so it's the light attack first, then heavy, and then the run button. Okay, that was a lot of setup, but we can finally start coding now. The first thing we're gonna code is switching between.
No,
And then you can
that's.
call this function later like any other built-in function. We want to call this function, we just want to call the action function that we created. Now we're gonna program the run button. So go into OBJ. In that case, I'll set alarm 0 to 16. Let's add the alarm 0 event now. Here, I'll simply destroy the instance.
Okay.
So when the switcher comes back into a game room, 1 second later, it will be destroyed. Now we can finally run the game and test this. Go near an enemy, touch it, and the battle begins. Click on the run button and you're back in the original room. The problem now, we did it, you'll come back to the room and the enemy will have disappeared. So with this, our turn-based.
There's currently no way for me to restore my health, and since I am forced to take damage in order to deal damage to this guy, and then the game restarts.
These battles are entirely functional. You can now go and fight other enemies and defeat them, or be defeated yourself. What's remaining are the bells and whistles, like animating the player and the enemy, and adding the heavy attack. So let's work on the animation first. The animations are gonna be pretty simple. The player will move forward and come back, and the enemy will also move a little and come back. Let's go into OBJ Battle Manager and open the create event. We're gonna edit the player attack function, which runs when the player wants to attack. Here we are simply gonna set an alarm in the player's battle instance. This alarm 0. Will trigger the player's animation. For the enemy, let's go into alarm 0. In the condition where we set alarm 1 so the enemy can attack, will trigger the enemy's animation. This is setting an alarm in the enemy. Its battle instance. Let's work on the player's
I think that's
animation.
supposed to be it
For that,
saving.
let's go into OBJ Battle Player. Let's go and add the alarm 0 events for the animation. This alarm will run every frame until the animation is finished. Here we're gonna increase the X position by 2 so it moves to the right. Then we check if it has moved 20 pixels to the right of its starting position, and in
This is slightly easier.
So it moves left. If the x is still greater than x start, meaning it's still to the right of where it started, we'll call alarm 1 again so it runs again in the next frame. Otherwise, it won't be called and the animation will stop. So the animation here is set up, and now we want to do the exact same thing in the enemy but in the opposite direction. Let's open obj battle enemy and here add the alarm 0 event. Here we're gonna reduce the x by 2. So it moves to the left. And if it is 20 pixels to the left of x start, we'll set alarm 1 so it moves back. Otherwise, we'll set alarm 0 again so it runs in the next frame. Let's add alarm 1 now to move it back. Here we'll increase x by 2, and if it's still to the left of where it started, we'll set alarm 1 again. Otherwise, the alarm won't be called and the animation will stop. So that was a lot of simple code for making this animation.
Okay. Test it. Yeah. So what's wrong with this? There we go. Okay.
Animation. Let's run the game now and see where we are. Go into the battle and fight, and you will see the animations happening. It feels a lot better now because it's responsive and it's giving feedback to the player for pressing the buttons.
Currently we have a game about pushing buttons.
We are in the final chapter of the video now and will enable the heavy attack. Remember the charge variable we made in the player? As you do more attacks, it will increase every turn. And when it reaches 1, you'll be able to do a heavy attack that does double the damage. For that, we want to draw the charge bar first. So let's go into the obj battle player object. In the
Gotcha.
draw event at the end, we're gonna move the drawing position a little and then draw the charge bar. I'll move the Y by the height of the health bar and set the new height to 4 pixels.
Hmm. drenched. Yeah, okay, I remember. Isn't it just this, though?
All we did for the health bar.
And then instead of green, put in blue?
And then I'll draw the colored part on top with the actual charge. So here everything will be the same, but for the width, I'll multiply it with the charge from the data struct.
Oh, right. Not HP. Okay. Let me just get rid of that real fast. Data dot charge.
And then for the color, I'll set it to aqua.
Close enough.
Now in the game, the charge will appear, but it will be empty. So we want it to increase every time the player attacks. For that, let's go into OBJ Battle Manager and open the Alarm 0 event, which is where the player attacks. Here I'm gonna increase the charge from the player's data struct by 0.4. It's up to you. How much you want it to charge every turn. I've chosen to go with 40%. Then to make sure it doesn't go above 1, I'll add that as it. The condition and reset the variable to 1 if it is above that number. Now we want to allow the player to do a heavy attack if this. Is at 1. Just go into OBJ action heavy. And for the create event from the parent, let's override it as before. Let's make the action function. And in the function, let's add a condition. To make sure that the charge of the player is at or above 1. Only then we can do a heavy attack.
Oh, right.
Attack. And in that case, we'll first.
Love you too. good night or good rest or whatever. Goodbye.
Reset the charge to 0 because you've just done a heavy attack. And now the bar is depleted. Then let's call the player attack function. We'll use the same damage from the player's data struct as before, but this time we'll multiply it by 2 because this is a heavy attack and it should do double the damage. Now let's go into the step event and override this as well. We are doing this so we can make the button transparent if the charge is below 1 to tell the player that
Close to finishing
you
it.
can't click it. So let's add a condition to check if it's either the enemy's turn or the charge is below 1.
Darn.
In either case, we'll set the image alpha to 0.2. Other otherwise, the alpha will be 1. So run the game and go.
Mm-hmm. I'm just gonna finish this guy off the normal old-fashioned way, and then boom. Nice. It works.
Go into battle. The heavy button will be transparent and clicking on it will do nothing. Do some attacks and fill up the bar. You may have to go into a second battle if the first enemy is finished. And then you'll be able to click on the heavy button and it will do twice as much damage. And with that, our turn-based battle system is finished. You can now move on to the next part, which is about leveling up and stats. So I'll see you there.
And I think that's where we're going to end today's stream. Let's see, is it this one? thank you for guys for watching. See you next time. In 2 days for Pal World. I will say, that was a lot more fun than I had anticipated. Now that I'm actually making progress, I also want to do a bunch more things like the role, like you saw. So it's not just me doing the tutorial. I want to actually try and see if I'm learning something from it. So, without further ado, I believe that wraps everything up nicely.